Good morning, everybody. Welcome. So class has started. So hopefully a lot of you guys came in early to get this warm up a shot. I'm on mute. All right. Well, let's try this. Now I'm not muted. Good morning, everybody. Thank you. I appreciate that. I hope you guys are all doing well. It's Thursday. The rain hasn't come yet, so we can enjoy the weather before it starts pouring. Um, I hope you guys are doing well. I know school is crazy. I know things are crazy, but I'm here to help you guys and try to make this as easy as possible. So if you guys have questions, make sure you guys shoot me an email or ask me a question in class so I can help you out, okay? Because I know this is really different and we're doing the best that we can, okay? So hopefully you guys had some time to try out this. So we did talk about a couple of classes ago about how do we know if something is a linear function. So if there's a graph, we can just look and say, hey, is this a line, right? And what we talked about was no curves, right? So we're looking for what we're looking for in a table though is we're looking for that our slope is the same. So if you don't remember this, right, what we're really looking for is we're looking for the change in output over the change in input. Okay, and this is our slope. Okay, and if this is constant, remember, constant is just a fancy word for the same. Oops, the same. Okay, so if it's constant, that's just a fancy word for the same, sorry. If it is constant, I'm going to write it down here, the same, okay, then linear. Okay, so if constant, then it's linear. So this is what we're doing here. So the change in the output, change in input, that's our slope. What we're looking for is it consistent? And consistent just means the same, then it's linear, okay? So, and again, guys, we're going to be having a midterm coming up really quickly. It's going to be next. So this is Thursday, so on Tuesday, we're going to have a review for the midterm, and then the midterm is going to be taken on your time, Wednesday or Thursday. Okay, but remember this midterm is open notes, so we're going to have a review next Tuesday. We're going to go over a bunch of problems, but make sure you guys are writing this down. You're writing down notes, so if you see something on the test, that you can just go ahead and look at everything, okay? Also remember that you can use your notes on the homework, right? And make sure you guys are doing that homework and submitting it. And if you have issues with that, make sure you shoot me or Miss Ortiz an email, okay? All right, so we're going to go ahead and go over these. So again, we're looking for the change in the output, change in the input. So right here, this is my input. This is my output. Right? We talked about function notation last time. We're going to talk about function notation a little bit more today. So we have our input, we have our output, okay? And so what I'm going to look for is the change. Is it the same on the input? And is it the same on the output? So from 3 to 6, right? That's 3, positive 3. From 6 to 9, that's positive 3. And from 9 to 12, that is also positive 3. Okay. And here I can go plus. So the change in the input, right? This is the change in input. Okay. So the change in the input is the same. Okay, so the change in the input's the same. So now we're going to look at the change in the output. So when we're doing change, change is done by subtraction. Okay, so just remember to find this, I'm going to go the second one, 30 minus 36. So 30 minus 36 is negative 6. Okay, Here, I'm going to go to the second minus the first. So I'm going to go 24 minus 30. Okay. And remember, we can be using calculators. There's going to be, you have Desmos calculator, or you can have a physical calculator. You can check these out from school if you need. So I'm going to go 24 minus 30 equals negative 6. Okay, and then this last one, I'm going to go 18 minus 24, always the second one minus the first one. So I'm going to go 18 minus 24, and I get negative 6. So take a look at these. The change, oops, there's an N in there, change in the output is the same. Okay. So the change, this is what we're looking for, the change in the output, the change in the input's the same. That means the slope is the same, it's consistent, and that's what makes a line. There's no curves. Curves are created by slope changing. A line has a constant slope. So we would say this is a linear function. Okay? So the first one is a linear function, and that's because the change in the input's the same, and the change in the output. I just said out, huh? The change in the output is the same, okay? So that's what we're looking for in a table to see if it's linear. After our midterm, we're going to spend a lot more time with linear functions, how to graph them, different ways to look at them. But for right now, we just have to remember, linear means line. Okay, so you either see a line or we do the table to see if it's a linear function. And thank you, Ms. Ortiz, for translating your wonderful, that's a lot of work. I appreciate you. Input, output. Okay, so we're going to the second one now. So I have input and output. Maybe I should switch colors, eh? Okay, so we're going to look at the difference in my input. And we're going to look at the difference in my output. And remember, the word difference means subtract, okay? And that's why I'm subtracting all of these, right? So I go 3 minus 1. 3 minus 1 is 2, right? So double check it. 1 plus 2 is 3. Cool. Okay. Next one. 5 minus 3. That's also 2. Okay. 7 minus 5. That's also 2. So it looks like our input is all the same, right? So change in input is the same. Okay, change in the input is the same. So all the change in the inputs are 2. Here, so again, I'm going to write these out. So I have 9 minus 2. Okay, so I'm going to go 9 minus 2, so that's 7. Okay, and then I'm going to have 20 minus 9, right? The second one minus the first one, so I go 20 minus 9, and that's 11. Uh-oh. Right off the bat, I can tell that I'm having issues here with the difference, right? 7 and 11, though that might be a good place to go get a Slurpee, doesn't have, it's not the same. Okay, so I'm going to go ahead and do the last one just because I can. So 35 minus 20 equals 15. Okay, so if we look here, these are not the same. Okay, not the same. Okay, so remember, for it to be a linear function, the change in the output and the change in the input need to be the same. So we're going to say not a linear function. Okay, and that's some good review, guys, and hopefully you have this in your notes. You remember, you can use your notes on the homework, you can use the notes on our midterm. I really hope you guys are using these notes to get your homework and midterm done. And if you guys have questions, make sure you're asking me. You can send me a question in the private chat so that no one else can see it. You can send a question to Miss Ortiz in Espanol in private chat if you would like to as well. Just make sure you guys are asking questions, because if you don't communicate with us, we can't help you, because I don't know what you need help with. Okay. All right. Let's take a look at what we're doing today. Okay. So today, let's go like this. I don't know what that symbol means. Were you trying to send a picture? If you try to send a picture, an emoji, sometimes it doesn't work. That is a really cool symbol, though. That almost looks like calligraphy or a symbol. Oh, it means what in Japanese? That's perfect. I didn't know you could get Japanese characters in the chat. That's really cool. Okay, so did you have a question? So when you're saying what do you mean by what? Oh, you're just being like showing off your cool Japanese skills. I'm not gonna lie. I'm a little impressed, actually. I'm a little impressed. Okay. All right. So let's move on to what we're doing. So today what we're doing 3.3, day 2. Right? So last class we talked about function notation. Today we're going to talk about solving in function notation. Okay? So let's review what we talked about last class with function notation. So normally we have y equals mx plus b, right? So what we have here, y is the output, right? M is our slope, b is our y-intercept, and x is our input. Okay, so what we're going to be doing here, guys, is this is what we're going to be working on after our midterm. We're going to be really focusing on this. This is a linear function. Okay. And we'll give it a name and everything, and this will be what we're going to be working on for the second part of this trimester, is graphing lines. What is a line? How do we do stuff with it? Okay, so this is old school notation, right? Function notation crazy, right? I'm writing the same thing again. Okay, function notation would just take this and change it to this. Okay, notice the only thing that's changing is the y, is my output. So what's happening here is this whole thing is our output, but then this right here is our input. See how our input is inside, right? And see how it's inside the parentheses? I like to think of inside input, inside input. So the x is on the inside, so it's the input, and the output is everything else. Okay, so that's the only thing that changed, and we worked on that. We worked on plugging in a value, right? So if so for example, this is just recap of last class. So from example from last class, we might have h of x, right? We can change this letter, it doesn't matter, it's just a different name, right? So this function's name is h. Equals 2x minus 3. Okay, so then we might say find h of negative 2. Okay, so we have to remember this is the input, okay, and all of this is the output. So really what this is saying find the output when the input is 2. So here we might say this. So it says find the output when the input is negative 2. Okay, that's what this is saying, but it's saying it in math. Remember, math is a language, which is why it can get so confusing what we're doing, because we're learning another language, right? So this is saying find the output when the input is -2. So we're going to find the output when the input is -2. So what does this look like? Okay, well, we're going to say h of -2. See how I'm putting in my input here. So everywhere I see my input, I'm going to put a -2. So again, this is my input. This is my input. Okay, notice how I put parentheses when I substitute. We should always be using parentheses when we substitute. Okay, now on this side, I'm just going to grab my calculator and I'm going to type this in. So I'm going to get 2 times -2 minus 3. Okay, and it looks just like this, doesn't it? And I hit enter, and I get, hey, h of -2 equals -7. So this is saying the output is -7 when the input is -2. Okay, and you guys, we have technology, so just use your calculator to get that done. All right. Okay, so that was a review of what we did last time. It's so important that I chose to do it again, okay? So this right here, okay? Now, you might see a word, and it's called evaluate. Okay, so I know we're working on word things. This is called evaluate. So notice how I said solving. So what we did last time is called evaluate, and we're going to work on this. But the difference is this is evaluate. So hopefully you have this in your notes. You see the word evaluate. Come back to this example. So when we evaluate, we're given an input, we find an output. When we're solving, we're going to do something a bit different. We're going to work backwards. So evaluate, this is when we get to use our calculator. Evaluate is the easy one. Solving, this is when we're going to do algebra. That's when we're going to not be able to use our calculator as much. I hope I'm making this clear. I'm trying to go nice and slow. I'm trying to build you guys up. Okay? All right, and again, if you guys have questions, you can go ahead and just write me a question in chat, or you can turn on your mic and ask a question. Either work just fine, okay? All right, I hope you guys are doing okay. So now let's get to solving, okay? So, and I'm just going to do this, guys. I'm just going to do this by doing an example. Oops, my pen's dying. Okay, so let's say h of x equals 2/3 x minus 5. Now remember, we're not scared of fractions, are we? No, you guys, we're not scared of fractions. In fact, let me grab my phone and get Desmos out. We are not scared of fractions. A calculator can do fractions for you, okay? So I'm going to make sure to show you guys how that works, okay? So we're going to have h of x equals 2/3 x minus 5, so this is linear, right? This is y equals mx plus b. So this is the function, okay? So we're going to find x when h of x equals -7. Sorry, this is my h. My h looks pretty bad, doesn't it? Okay, so this is my function, and we're going to find x when h of x equals -7. Okay, so what we're going to do here is the first thing we're going to do is notice this. H of x equals -7. This is the output. Okay, right, because this is my input. So notice how this is different already. I have my output, but I want to find my input. This is like Jeopardy, right? You have the answer, you want to know what the question is. See how it's working backwards. And that's what makes algebra so hard, is that we're going to have to work backwards, okay? So again, we're given the output and we have to find the input. That's how you know we're solving, because we're working backwards. Solving is working backwards, okay? So notice here, my output here. Well, isn't this my output right here? Okay, so if my output equals -7, can't I replace this with -7, right? That's substitution, okay? And it's something we do a lot in algebra. So what I'm going to do here is I'm going to take this -7 and I'm going to substitute it, and then I'm going to draw out the rest. Okay, so, right, I replace h of x with -7. Okay, and this was given, right? This was given to us. So that's all I did. I just replaced the output with the output. Okay, so next step, okay, now we're going to solve for x. So taking a look at this, I want to get this term by itself, right? So the first thing I'm going to do is I'm going to get rid of any terms that's on the same side. So this says -5. So I'm going to do the opposite, right? Because I'm solving. So I'm doing everything backwards. So I'm going to add 5 to both sides. Okay. So again, I'm showing my work. I'm going to get this presentation mode. So I'm going to go -7 plus 5. Okay, and I get -2. Right? We're not going to make arithmetic errors because we get calculators, and the calculators will do it all for us. Okay? Now, how do you do fractions? Guys, there's 3 different ways you can do fractions. So I'm going to teach you 3 different ways. Okay, I'm going to teach you 3 different ways, and I want you to pick the way that works best for you, and you're going to do the way that you like most, right? So I'm giving you options, okay? So, the first way is, this is 2/3 times x, right? This is 2/3 times x. What's the opposite of multiply? It's divide. So I'm going to divide both sides by 2/3. So I can do this really easy in my calculator. I'm going to clear all, I can go -2, right, divided by, and then I can do a fraction, 2/3. Okay, and then it's -3. See how easy that is? That's it. So we have to get good at using calculators, okay? So that's one way of doing it. The other way of doing it is a little bit longer. So you can think of this as 2 times x divided by 3, or like this. See how we rewrote it a little bit? So you can think of it as 2 times x divided by 3. Well, so we can just do, this is a little bit longer, but we can do smaller steps. I don't want divide by 3, so I'm going to multiply by 3. So I get -2 times 3, and that's -6. Thanks, phone, for doing that. Nope. Okay, and then that equals 2x. And then we can say this is 2 times x. I'm going to divide by 2, right? And then I can divide, oops, I got to clear out, -2, oops, -2, nope, 6, nope, -6 divided by 2. And what do I get? -3. And notice how my answers are the same. Okay, so again, guys, do you see how this one maybe is a little bit easier with the calculator, right? But if you didn't have a calculator, you still could just do multiplication and division. Okay, so those are two different ways to solve that problem. Okay, I just wanted to give you a little, there's more than one way to do things, right? There's always more than one way. And on our midterm, you're going to find that it's going to ask questions like, hey, how's that going? I see someone has their hand up. How can I help you out? So if you have your hand up, you can ask a question in chat, or you can turn on your mic and ask a question. Nope, don't have a question? All right. Okay, so that was our first example. Let's do another example, and then I'm going to have you guys try one out. Okay? Here, let's do this one. So let's do g of x equals 1/3 x minus 2. We're going to... What's up? Okay. So, so this is our next example, 1/3 x minus 2. We're going to find x when g of x equals -4. So we're going to go a bit faster this time, okay? So I have a function. It's linear, right? Because I have mx, plus my b. We're going to find x. So again, this is my input. When my output equals -4. So to solve this, I'm going to replace my output with -4. Like so. I'm gonna get this x term by itself. So I'm gonna get -2 equals 1/3 x. And then I don't know about you guys, but I think using the calculator is the fastest way here. I'm going to divide both sides by 1/3. Okay, so what do we get? We get -2 divided by, and then I do the fraction button, 1/3. And I get -6. So -6 equals x. Okay, so I'm going to stop there for a second. Are you guys feeling okay with this? Okay, I got a person doing the check mark in participation. Okay, that's cool. If you guys want to do that, that's great. I can see it. I can see that you're doing well. Or you can use chat to be like, hey, I'm doing okay. Or you can send me a private message. I really like the private message. And you can be like, hey, I'm doing okay, or I'm not doing okay. Because if you're not doing okay, this is a good time to ask so I can help you out. Okay, I appreciate the private messages. Okay, so I'm getting, some people are feeling really good. I'm getting some people, they need a little bit more practice. So we're going to stay on this for just a little bit. Let's do one more. Okay, I'm going to have you guys try this on your own. And see how you guys are doing, okay? So we're going to say f of x equals 6x plus 9. And we're going to find x when f of x equals 21. Okay? So I'm going to have you guys try this on your own. I'm going to give you 1 minute to work on it, and then we will talk and see how it's going. Okay, I'm going to give you 1:30. Okay. All right, guys, let's go ahead and take a look at this and see what we can get here. So again, my output here is 21. So the first thing I'm going to do is I'm going to replace f of x with 21. So I'm going to have 21 equals 6x plus 9. Okay? Because the output equals 21. So I'm going to replace the output with 21. So I'm going to go ahead and solve for my input now. So to do this, I'm going to subtract 9 from both sides. Okay? So again, I hope you guys are using calculators, right? So 21 minus 9 is 12. Okay, this is 6 times x, right? So I'm going to divide by 6. And then I have 12 divided by 6 is 2. I'm sorry to hear that your internet's not working. Do the best that you can. If for whatever reason you missed something in the lesson, all of this will be on YouTube. So if your internet gets working again, you can go back and look at everything on YouTube. And I'm really sorry that you're having internet troubles. That's super frustrating. Okay. Hey guys, I'm going to move on to get up some other stuff. But at the end, we're going to come back and try this again. Okay? We're going to try this again. So, there's one other thing. So function notation and graphs. Okay, so I just want to talk about function notation and graphs. So I'm going to draw a line for you guys. Okay. And I'm going to go 1, 2, 3, 4. 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 Okay, so this is my y, this is my x. So my input's up and down. My input is left to right, my output is up and down. And I'm just going to do some points here. Okay, so, and you guys, I know copying this down will be difficult, but you guys can just look at mine really quick. So this is a graph, right? And let's call this f of x. Okay. Now, we don't know the equation for f of x, but it might say find f of negative 2. Okay. So some things that we need to remember here. This is my input, or my x, and then this is my output, or my y. Okay. So what they're saying is that we know our input is negative 2. Okay. So on here, what I'm going to do is I'm going to want to go left 1, 2. This is negative 2. Okay. And I want to know what my output is at input negative 2. So my output is up and down. So I'm going to go down here, and it looks like my output is at negative 2. So this is negative 2, negative 2. Okay, and the notation for this is at x, f of x. Okay, so input, output. Okay, so my input was negative 2, my output is negative 2. Let's do one more example. So we're going to find f of 3. Okay, so again, this is my input, or my x, and this is my output, or my y. Okay, so I know my input is 3, so x is my input, so I'm going to go write 1, 2, 3, and then I go up to the graph. See that right there? And then I want to figure out what it is over here, and it looks like it's 1, 2, 3. So this point is at 3, 3. Okay, so I can write, so how do we write our answers? I should go over that. F of negative 2, what did we get? F of negative 2 equals negative 2. And what did we get for this? F of 3 equals 3. Okay? So that's what function notations looks like there. Okay, just wanted to make sure you guys knew that. Anybody have questions? Are we okay with that? So if you don't have an equation, but you do have a graph, you can still find outputs. We're just plugging in inputs and figuring out where is the function on that graph. Okay? So for example, like this, right? At this point, we went down 2 over like this. Okay? There will be some homework problems like this. Okay? No one has asked any questions yet, so I'm just going to assume that we're good. And I want to go on to the last thing we're doing today. All right. So the last thing we're going to be doing today is graphing a line. So graphing a line with function notation. Okay. So there's a couple of things that we're going to need here. We're going to be graphing a line with function notation. So there's the things that we're going to need here is, one, we're going to need a table sorry, looking at my notes, the last where I was. We need a table with 5 inputs and outputs. Okay? The reason why I say on 5 is on your tests, it will ask for 5 points. Okay? So we need to make a table with 5 inputs and outputs. Now you're like, well, how do I know which ones to do? I got you guys, okay? I'll help you out and figure out how to do that, okay? Because it's really just a guess and check game. And you try some numbers, and if it doesn't work out, then you try some other numbers. And I'll show you that in just a second, okay? Okay, and then, so once we do this, then it's really easy to do it, okay? On your homework, you will only need 2 points. Okay, so I just want you guys to be careful. On your test, it's going to ask for 5. On our homework, you only need 2. It's just the way that the software is set up. So the homework is going to be a little bit easier, so we're going to get used to making a table with 5 points. So let's go ahead and let's do an example together, because sometimes just taking notes is confusing. Let's add an example and see if this helps and gets you guys going. Is there a question? How can I help you? So I see a hand raised in participants. If you have a question, you can type it into chat. There's a chat box. Oh, okay. So if you're just stretching, then you can go ahead and stretch. And I appreciate that you should be stretching. This is a lot of time in front of a computer. Okay. All right. So let's take a look at an example of this. Okay. So an example of this would be, we're going to graph f of x equals 3 minus x. Okay, so this is a a line, right? We have a x term with something in front of it and a number. Okay. So to do this, we're going to make a table. Now, what I always do so here's a note. Sorry, those are supposed to be stars, my star game. So here's just a note. Try your table from -2 to 2 for the inputs. Okay? Try your table from -2 to 2 for the inputs. And I'll show you what that means in just a second. This won't always be right, but it's a good place to start. Okay? Later, we're going to learn more about these functions, and we'll have more of like a concrete way of knowing how to set up our table. So I'm going to make a table. So I have x. I have f of x. Remember, this is my input. This is my output. And I'm going to make 5. So I'm going to go -2, -1, 0, 1, 2. Run out of room there at the end, didn't I? Okay, so this is what I mean. So we're going to just start with my input from -2 to 2, and then we're going to see if it makes sense. If it doesn't make sense, then I'll go back and change it, right? So it's not a big deal if it doesn't work. So what I'm going to do here is I'm going to just plug these into my calculator. So for this one, right, my input is -2. So for my output, I'm going to have 3 minus -2. So on my calculator, I'm going to go 3 minus, and then I always use parentheses when I plug in, right? Always use parentheses when I substitute in, because remember, f of x is 3 minus x, right? So I'm plugging in -2, and I get 5. So again, you see how using a calculator here can be really helpful. So this one, next one right here, I'm going to have 3 minus a -1, because it's 3 minus x. So I'm going to have, I can just go right in here and type in a 1. That's really nice. So I get 4. Okay, and then I'm going to want 0, so I can just replace it with a 0. So again, this is 3 minus 0. So I get 3. And then for 1, I'm going to go back here and replace it with a 1. Okay, so again, this is 3 minus 1. So I get 2. Hopefully you guys see a pattern, right? And then I'm going to replace that 1 with a 2, and I get 1. Okay? So that's making the table. Okay? So when we're making the table, you might want to start from -2 to 2, and then we're just plugging our inputs into the function to fill out the outputs. Okay? And here I was showing my work. Notice how I'm replacing the x with my input. Okay? So once you make the graph, the table, we're going to go ahead and sketch a graph of this. Okay? Now, on your homework and on your test, your graph is going to be a fixed size. So to do this, I'm going to go like this. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So I made this 4 by 4. Okay, this is my y, this is my x. Now the reason why I did that is you're going to see that not all the numbers I picked are going to fit on this 4 by 4 graph. And that's what I'm trying to say, is that, hey, we tried -2 to 2, but sometimes -2 to 2 just doesn't work for the graph that we do that. Why did I use 3? Because it was just the number I thought of when I came up with this. This number can be anything, right? So so like this is just made up. I just picked a number out of my head. I picked 3 because it's an odd number, it's prime. I like it. Okay, so f of x equals 3 minus x is just it's just a random number. Okay, all right. So what I'm going to do now is I'm going to plot these points. So when I first look at this, -2, right? 1, 2. So this is -2. This is -1. This is 1, 2, 3, 4. Well, at -2, it's supposed to be an output of 5, but that doesn't fit on my 4x4, does it? Okay, so that's not, I need another point, don't I? So I can't graph that point. So the next point I'm going to look at is -1. At -1, I'm at 4. So I'm going to go 1, 2, 3, 4. So this point is at -1, 4. Okay, so I have -1, 4. This is my x. This is my f of x. Okay, so let's go to the next point. 0. So 0 is right here on the x. I'm going to go up 3. So 1, 2, 3. And I get 0, 3. Okay, and then I go to the right 1. So I go right 1. I go up 1, 2. Right, this is at 1, 2. And then my next one is at 2, 1. Okay, now how many points do I have? 1, 2, 3, 4. I need 5. So this one didn't work, right? So all I'm going to do is I'm going to come back up here. I'm going to extend this out. And I'm going to say, okay, let's just go one more in this direction. Okay, so to do that, it's going to be 3 minus 3. 3 minus 3 is 0. So then at 3, I know I'm going to be at 0. So this is at 3, 0. So I go and then I'm going to connect them like this to make an arrow. Okay, and we did it. That's the graph. So again, if we need 5 points, see how I have 5 points here, and one of them doesn't fit on the graph, I can just, hey, I'll just have to expand out my table and try some different numbers. Okay? So that's how you graph a line. Just use a table. It takes a little bit of time, but you're going to get it right all the time. So that's really exciting. Okay? So we're looking for these points. How am I doing for time? 9:48. Okay. So I did want to have some time to go over some extra problems, but it's 9:48, so I only have a couple of minutes. So I just want to make a note really quick. On your homework, your big ideas homework. Okay, on your big ideas homework. Here, in fact, I'm going to log into Big Ideas really quickly, and I'm going to show you what I mean by this. This is signing in with Google. Okay, I'm going to share the screen. Let me find. Oop, I'm in the wrong class. That's what happens when you're a teacher, huh? Okay, so I'm going to preview. Oops, I didn't want it with answers. Here, without answers. Sorry guys, just a second. I really wanted to show you how you're going to do your homework. And this is taking longer than I thought, and I'm really sorry. Okay, so of course it's loading. Okay, so to graph, okay, right here. So it says graph the linear function p equals 4x. Can I zoom in? Can you guys see this? Okay, so what I would do is I would get a point, so I would make a table, right? So to graph this, it has a line. What you're going to do is you're going to take 2 points to make a line. So for example, what is 4 times 0? 4 times 0 is 0. So I would put a point right there. Do you see how a point shows up? And then I need one more point. So if I go over to 2, what's 2 times 4? 2 times 4 is 8. And as soon as I do that, do you see how it draws the line for me? Wonderful, okay? Now remember, on the test, you're going to have to make a table and do 5 points. but for your homework, you're just going to need 2 to graph a line. So again, to go over this, I'm just going to need 2 points. So if I plug in 0 for x, 4 times 0 is 0. 2 times 4 is 8, or I could do 1 times 4. 1 times 4 is 4. So it doesn't matter what points you use. Just make sure you're practicing using 5. Okay? Guys, that takes me to the end of class. So does anybody have questions or comments? If you do, then you can stick around. If not, then you can take off, and I will see you guys on Tuesday. And Tuesday will be a review day for our midterm. So take care, guys, and if you need anything, please let me know.